Hello, in this video I will show you how to solve the exercise over allocated resources. First, we need to explain something. The task number 1 have a successor which is task number 2, and task number 2 have a successor which is task number 3. So it also means that the predecessor of task number 2 is task number 1, and the predecessor of task number 3 is task number 2. It will help us to make our diagram on the software Gantt project. So here we will create our two first tasks. So the first task is done by the designer. So first we need to create a resources, and we put the name designer. The second task is done by the programmer, so we also need to put programmer. Now we can create the task. So you can go to Gantt. Before creating a task, just make sure that you have all the calls that you need. So we need the name of the task, the resources, the duration, the predecessor, the beginning date, and end date. If there is a calls missing, you can just manage columns and add and select a new calls, show selected or hide selected. So here we will create our new task. It's task number 1. The resources is the designer. So we will go to resources and add the designer. For this task, there is no predecessor, so we don't have to think about that. The duration is 4 days, so we'll put 4 days. And at the beginning date, I will just put the date of today, 23rd of October. Then we can create the second task. So we create a new task, which is task number 2, which is done by the programmer. So we can just add the resources. That time we will add the programmer. And this time there is a predecessor. Predecessor of task number 2 is task number 1. So we will just add task number 1. The duration of this task is 8 days. So we can put just duration as 8. Here you can see that the chart is drawn automatically, and the beginning date and end date are done automatically. So now you have to proceed like that for the rest of the task. So here we are. We have created all our tasks with the resources, the duration, and the predecessor. So now let's have a look to our resource chart. We have 3 resources and all the tasks that they have to perform. And there is the schedule made by the software automatically. But here we have a problem. The programmer is working 200%. It means if the normal day for a programmer is working 8 hours per day, here you need to work 16 hours per day during 6 days, which is not possible. People should not overwork like that. So we have to find a solution, because if we stay like that, our programmer will not be able to perform the job as planned, and it will cause delays in our planning. So the idea is to find a way that the programmer is not working overtime for 6 days. So let's have a look. Why the programmer overwork? Because at the beginning, perform task 8 and task 9 at the same time. And at the end, he performed task 2 and task 9 at the same time. So we can see that probably the problem is the task 9. So let's have a look to Gantt. We can show the critical path. Here we are. So the task number 9 is not on the critical path, so we can move it, but we have to be sure that we are not moving anything on the critical path. The task number 9 is the predecessor of task number 7, and that's all. And there is no predecessor of task 9. It means that we can move task 9 wherever between the beginning, but he has to be finished before the beginning of task 7. We don't want to move that because task 7 is part of our critical path, and if we delay the critical path, our project would be delayed. So task number 9 is have a duration of 6 days. Now let's look at the resource chart. Maybe we can find a place where the programmer is not working for 6 days. Let's have a look. Here there's 4 days, and here there's 2 days. Here there's a lot of time, but if we put it here, it means we put it before task number 7, after task number 7, so we will remove the critical path. So we have to find 6 days before task number 7. We don't have 6 days in a row, but we have 4 and 2. So let's have a look what we can do. So one solution is to divide task number 9 into 2 tasks, 9.1 and 9.2. They are both for the programmer. The first one is 4 days and the second one is 2 days. 4 plus 2 equals 6, so we are good. It's the same duration as the initial task number 9. The start day of task number 9 is exactly the same, and we just put task number 9.2 right after task number 9.1. Does that change anything? Right now, no. The programmer is still working 200% at the beginning. But now, let's try to move this task. Task number 9.1 have a duration of 4 days. And after task number 2, there is a space where the programmer is not working 4 days. So we have to move the task number 9.1 after task number 2. Let's do that. Task number 2 finish on the 7th of November. So let's put task number 9.1 just 1 day after that. Here we are. But now we have a problem because task number 9.2 should be after task number 9.1, and so we have to change all the beginning date of task number 9.2. Let's see when we can put that. So you see now there's just a problem of 2 days here. The problem on the beginning disappear because we changed the date of the task. So now let's see where we can put task number 9.2. It have to be after task 9.1 and when the programmer is free, and before task number 7. So here we are. There is a spot here of 2 days. It's right before task number 7 and after task number 9.1. So we will do it after task number 4. Task number 4 finish on the 90th of November, so we just have to put it right day after that. Here we are. Now let's have a look to our resource chart. There is no problem anymore. The programmer is working every day, but with not overtime. So it's what we want for our project. Our resources are used, but they are not over busy, so they can perform the work properly and our planning can be respected. So here we can see that without changing the critical path dates, just by changing some tasks during our project, we can find a solution to allocate our resources properly with the same schedule as